The term congruent means it is of same shape and same size. Same shape and same size. Okay. Generally, not only for triangles, when you say congruent means they are exactly equal. One will fix on the other thing. Like this, it will be a same thing. It looks like. Okay. So same shape, same size for all the shapes. When it comes to triangles, this terminology, same shape, I said, right? Both should be triangle. Same shape, obviously, triangle. When they say same size, the same shape includes all the angles should be equal. Then only it will be of same shape. Okay. If all the angles are equal between two triangles, then it's the same shape. Now, same size means the sides should be equal. Take two triangles. I am naming it as A, B, C. This is D, E, F. Suppose when we can say these two triangles are congruent, these two should be of same shape. Same shape means what? Angle should be equal. What are all the angle equal? Angle A equal to angle B. Like this I am taking. If this angle A is equals to angle A, and then this angle B is equals to angle B, angle B is equals to angle B, and then this angle C equal to angle F. You notice one thing? Here I put one line, here also one line. This one lined angle is equal to one lined angle. That is what it means. When here also one line, there also one line means. Okay. When we speak of congruency. Here two lines are there. Where two lines are there in the other diagram? Here. So those two are equal. Then here three lines are there. Those three are equal. Okay. So it is of same shape. All the angles are equal. And same size. When it will be same size means the side AB should be equal to the side ED. Also, the side BC should be equal to side DF, and then the side AC should be equal to EF. So, this gives that same shape. This gives the same size. Okay. Then we can conclude that this triangle ABC is congruent to triangle DEF, like we may say. So these two triangles are congruent, like we can fix. But the point is, if we write like this, which is equal to which angle, we don't know. Is it? Suppose we don't know this, only this is given. Which is equal to which angle, we don't know. So the correspondence is very important. What is the correspondence? What I mentioned here, angle A is equals to angle B. So from this we can able to understand all these details. That like should be this should be written. Simply, when you write DEF means these all the things will be collapsing. Is it? So I will be writing and triangle A is equals to what? E. And then B is equals to D. And then C is equals to F. If I mention like this, triangle ABC is congruent to triangle EDF. Now this has a correspondence that angle A is equals to angle E, angle B is equals to angle D, angle C is equal to angle F. Only angles. Side also it should come. What is that side? The side AB, first two. Here first two equals to AD. Correct? Likewise, next two you take. Side BC should be equal to DF. Okay. Then another combination, first and last. Here first and last. AC equal to EF. That is how this congruency works. Okay. Suppose this is given, it means that all these things are in this itself. Okay. Angles na corresponding alphabets you should see. Side means two consecutive things you should relate. Got it? Okay. Now, totally we have to check 6 conditions. Is it all the angles are equal? You should check. Also, all the sides are equal. Like we should check. Now, this takes lots of time, isn't it? We have some other easier way. So, those easier way only given by the congruency criteria or congruency rule. Someone will say congruency axiom, condition for congruency, the sufficient condition. Instead of checking all this, with some few conditions we can confirm whether this is congruent or not. That is what it is called as congruency rules. Okay, you understood what is congruency? Okay, what is congruency say? Shall I erase this? What is congruency? Shape should be same, size should be same. What makes the shape equal? What makes the shapes are equal? Their angles. When the angles are equal, we say it is same shape. What makes the size are equal? Good. Okay. So we got 6 conditions. Instead of 6 conditions, if you can able to check only few things. What are the few things? We have 2 conditions that same shape and same size. Okay, if we have this alone, that means all the sides are equal. If all the sides are equal, we can say those 2 triangles are congruent. This condition need not to be checked. Okay, for example, take these 2 triangles ABC and this triangle DEF. If we got to know that the side AB is equals to EF, the side BC is equals to DE, and the side AC is equals to EF. You notice one thing? This one lined side is equal to the one lined side there. Okay. Here 2 lined side is equal to this. BC is equal to which side? The AC is equals to. So if we have AB is equals to DE and not DE. AB is equals to DF and BC is equals to DE and AC is equals to EF. Okay, only the second condition applied. We got all the sides are equal only. Then we say directly, you can say, we don't need to check whether the angles are equal or not. Directly you can say this triangle ABC is congruent to triangle. We should not write like DEF. Is that all right if I write DEF? That should contain these details. Okay, try mapping this A with B, B with F. Wherever B is there, F is coming or not? No, it is not. BC or D. Okay, then try mapping the other B with B, A with F. So wherever A is there F will be there, is it? That like we'll fix on mapping first. Then A, B, C I written right, D, E, F we should not write. These details should be conveyed in this one line. The side AB is equal to what? DF, but as per the other conditions, we map the A with F. I am naming it as FD. Okay. And the side BC is equals to DE. Already DE is here. E. Okay. Now whether this all the things conveyed in this one line or not. First 2 is equals to first 2. Last 2 equals to last 2. First and last is equal to first and last. Okay. We should name this. If only all the sides are equal, we say these triangles are congruent, right? That is what is called like SSS congruency. Where this S stands for side. Okay. Simply they mention SSS congruency rule or SSS congruency axiom. Okay. So using what, on what basis we are saying they are congruent. That is what we are conveying here. All the three sides are equal. Similar way, there is a congruency rule called SAS congruency rule. You guess what? S means side, A means angle, and then S means side. Not only that, that angle should lie in between the side, mention the side. Okay. So here, take two triangles, ABC. Why always DEF? Let me take some X, Y, Z. Why this much stuff? PQR. Triangle PQR. If we got to know that this angle A is equal to angle Q and the side AB is equals to QR, AC is equals to PQ. What happened here? We got, AB is equals to QR like I said, right? What happened here? Angle A equal to Q we know. And the side containing the angle also equal. Okay. So, one angle is equal and the sides containing the angle. This angle A lies between which two sides? AB and AC. This side AB is related to where this Q, that side QR. And then this AC is equal to PQ. Okay. Got it? So all we have is only one side equal, only one angle equal and the sides containing the angles are equal. Using this, we can say instead of checking all the 6 conditions, we checked only 3. Okay. So we call this is SAS congruency. This triangle ABC is congruent to triangle. What you guess? This all the details has to be conveyed in this way. A should be equal to what? Q. So A related with the Q. Then B related with the or C related with the P. Like this, you do some rough mapping using pencil. After that, we can write A, B, C means what is the order? Can you say? A mapped with what? Q. Okay. A is equal to Q. And then B mapped with the B mapped with R. And then remaining only one alphabet. This with P. So here all the details conveyed. A is equals to Q. AB is equals to QR. And then BC is equals to, not BC is not there. AC is equals to QP. Okay. This congruency criteria is called as SAS congruency criteria. Okay. Now there is some another congruency rules. Shall I raise the other side? There is a congruency criteria called AAS. Okay, guess what AAS will be? Angle, side, which means two angles are equal and meaning one side will be equal. Okay, so here take two triangles PQR STU, like I am taking. In that, any two angles will be equal. Angle Q is equals to angle S, angle P is equals to angle U, and then the side Q is equals to the side ST. Sorry, QR is equal to the side ST. What I have here? Two angles and one side. Okay, then we can write what? This angle P is equals to angle U, angle Q is equals to angle S, and then the side QR is equals to ST. Okay. Now all these details we have to convey in the congruency relation. First triangle, as this you can write triangle PQR, alphabetical order I wrote. While writing next only we should be really careful. That is congruent to triangle P. P is equal to what? U. And then Q. Q is equals to yes. And then R is equals to. We don't have any relation for that. This mapping we can do. Q is already related. So R U S. Got it? But here, while using AAS congruency, we have to be really careful that which side we are dealing with. You see, this equal side is connected with this one-lined angle, is it? There also equal side is connected with one-lined angle. Okay, so we say it is congruent. Sometimes what may happen, this triangle PQR, the same triangle STU, let me take, the same relations also will assume, and then instead of here one side, there one side equal means still we have two angles and one side equal, but are they corresponding sides? What does it mean that corresponding? Which connects with what? That is not corresponding. Here this equal side is connected with which side? Sorry, which angle? Double lined angle. Okay. Here equal side connected with which angle? One lined angle. Though two angles on the one side are equal, we cannot say these two are congruent. Why? Correspondence is missing. Okay. This case you should be aware of. Here AAS will not be applied. These two triangles are not congruent. Okay. How do you do not congruent? In this case, this triangle PQR not congruent with the triangle STU. Not congruent only, right? You can write whatever it is. Okay. Got it? You got the understanding between these two, ASA congruence and this. Now there is another congruency rule. You understood or not? Okay. Next, another congruency rule, that is called ASA congruency rule. Guess what? Angle, side angle. Where that side will be? Between two equal angles. Take these two triangles, XYZ and M and O. we say angle M is equals to angle Y, and then angle Z is equals to angle N, and the side Mn is equals to YZ. Okay, got it? You noticed one thing, two angles are equal and the side common for both angles is equal. Here also two angles and one side equal, but it is ASA congruency. Why? That side lies between the equal angles. So that is why we call it as ASA congruence. You say the congruency relation, this XY is a, oh no, you are now only you are practicing, right? This angle X is equals to, we don't have anything, angle Y is equals to angle M, I said, and then angle Z is equals to angle N, and the side YZ is equals to Mn. Now you say the relation, this details has to be conveyed in a way that XYZ is congruent to triangle. In place of X corresponding to X, what has to come? Don't know, don't bother. Corresponding to Y, what should come? M. Corresponding to Z, N. What is left? Oh, that's all. Got it? So it always based on which detail we got. So far we have seen about 4 congruency rules. First one, SSS congruency, all the sides are equal. Next, SAS congruency, two sides and the common angle is equal. Two sides and the included angle is equal. And then AAS congruency, in that two angles and any one side should be equal, but that side should be corresponding side. And then this ASA congruency, two angles and the common side for the both angles should be equal. Got it? Now one last congruency, with that we will finish. Shall I erase? Okay. See, the last congruency is specially for right angle to triangles. You know about right angle triangles? Heard this before? Now only I said, right, if one angle is 90 degree, that is called right angle triangle. In that, you know, the side opposite to 90 degree, we call it as hypotenuse. How do we call it? Side opposite to 90 degree? Hypotenuse. In two right angle triangle, when we compare two right angle triangle, if we have one angle already equal, right, where this R stands for a right angle and H stands for hypotenuse and S stands for any side. Okay, so already right angle equal, hypotenuse should be equal. This side and this side is equal, and any one side, it could be any side. Here this side and this side also can be equal. Okay, then we should say accordingly, like we have angle A equals angle E, that each are 90 degree because they are equal, and the hypotenuse, what is this? CB equals to DF, that is hypotenuse, and the one side equal, that is CA and EF. Okay, that is side. So right angle, hypotenuse, side, these three are equal. Then we can say this triangle ABC is congruent to triangle. Say the correspondence. A is equals to what? E. And then from this we can correspond. A corresponds to E, and then C we can relate with the F. Then B corresponds to what? D. So EDF. Okay, this congruence we call it as RHS congruence. Okay, we'll summarize everything once. There are few congruencies we assume. Shall I erase this one? This way looks like confusing to you. You got confused or clear? Okay, two triangles, we have to say 6 conditions should be equal. Then only we can say these two triangles are congruent. Okay, instead of saying all the 6, based on the available data, suppose if only 3 sides are available, we say SSS congruency. That included angle, 2 side and 1 included angle is equal, we say SAS congruency. And then 2 angles and 1 side, any one side is equal, but that side should be corresponding side. We have to be clear with this. Okay, then that is AAS congruency. And then if that side, equal side lies between these two equal angles, means that is ASA congruency. And for right angle triangles, it is RHS congruency. Apart from that, there is no other congruency. That you have to fix in your mind. You should not think that only SCA only right. S means side, A means angle. We can write SA, SSS and all likewise, you should not write. Okay. Only these 5 fixed are there. Apart from that, there is no congruency. You should not create your own congruency and all. See, SSA congruency, like people may say. It is not congruency. It means Sarva Shiksha Abhiyan, central government scheme. So this is not congruency rule. But this looks like the congruency rule, but it is not. Only these things are available. Fix your mind. Okay. In the next session, we will be revising all this and we are going to use this in the questions and we will finish off this 9th one. Okay. But before that, I want you to revise everything. Simply. If not everything means, at least this congruency rule. Got it? If time allows means, now itself we will see one example, but time is not sufficient right now. Next session, we will see some questions, we solve this using this congruency rule, but revise all this, have a clear understanding about triangles. Okay. Then we will see the next things. Any other doubts, clarifications? Do you feel confused?